Now friends, I am having a problem from CAT 2005. This is the set of 3 problems based on the given information. In the given figure 1 and 2 are circles with center P and Q respectively. The two circles touch each other and have a common tangent that touches them at point R and S. These common tangent meets the line joining P and Q at O. The diameters of 1 and 2 are in the ratio 4:3, and it is also known that the length of PO is 28. Now the very first question is, what is the ratio of length of PQ is to QO? Right? Now what we do, friends, it's a problem, a very simple problem based on the concept of similar triangles, right? What I did, I matched PR and QS, right? Now this is radius and this is also radius. Now ratio of diameter is 4:3. That means the ratio of radius will also be 4:3, right? That means this ratio is 4:3, right? Now the triangle OSQ and triangle ORP, both of them will be similar, obviously, because this angle O is common and SQ will be parallel to PR because this angle is 90 degree, right? Tangent and angle between tangent and radius is 90 degree, right? So OSQ and ORP, both of them will be similar. Now if the two triangles are similar, their sides are in proportion, right? Now this the ratio of this and this is 3:4. That means the ratio of OQ and OP will also be 3:4. OQ by OP. OQ is the side of this triangle and OP is the side of the bigger triangle. So OQ by OP will also be 3/4. Now since OP is given to us as 28. That means 4 into 7, that means this must be 21. That means OQ is actually 21. That means PQ must be 7 because this complete length is 28. OQ is 21. That means PQ must be 7. Now we have to find out the ratio of PQ to OQ. OQ is 21, PQ is 7, so the ratio will be 1:3. So we observe that we didn't go for any sort of like detailed paperwork, right? A simple concept of similar triangles have been applied over here, right? Now let's see what is the next question. Now the very obvious thing over here is this PQ is the addition of the radius of both the circles, and the diameters are in the ratio 4:3. That means the radius will also be into 4:3. Now length of PQ is 7. That means the radius is 4 and 3 as well, right? Now let's see what is the next question. Now here it is asked what is the radius of circle 2. That means the smaller circle, that's 3, that we have already calculated, right? Next one. Now we have to calculate length of SO. So let's see what is that. SO is this length. Now this angle is 90 degree. This length is 3 because this is 3. Radius will be 3. So I remove the K. Now this is 3. OQ, we know that it is 21. Right? Now this is OS will be 441 minus 9. Like OS square will be square of OQ minus a square of QS. So that is 441 minus 9, right? So OS is root 432. Now let's see the options. So I just write it over here. Root of 432, that's root of 144 into 3, right? So 144, if it comes out of the square root, it will be 12. So the length is 12 root 3, right? Very simple questions, and we have solved 3 questions based on a single given information, right? That means 12 marks, right? And it hardly took 3 minutes to solve all the 3 questions, okay? So friends, the questions based on similar triangles are asked very frequently. So you should be clear about the concept of similar triangles, right? We have done so many problems on that. I'll be taking more problems. Just wait for a moment. Now friends, once again, the problem from CAT 2005. In this case, ED is parallel to AC. AC is diameter, CBE is given as 65 degree. We have to find out the value of DEC, that is DEC, that is this angle. Now friends, since these two lines are parallel, that means this angle will be equal to this angle, right? Now I match this. Not able to draw a straight line. Wait for a moment. Okay, now this length will be equal to this length. Both of them are radius. Now you can see the segment EC. On this segment we have one angle at circumference that is of 65 degree, right? So according to the like properties of circle, the angle from the segment at the center will be double of that. So if it is 65, it has to be double of that, that is 130. Now we can see the triangle OEC. These two angles are equal, right? Now we are left with just 50. That means this angle must be 25 degree and this must be 25 degree. Now this angle is equal to this angle. If it is 25 degree, it has to be 25 degree, right? Very simple problem, friends, and it is of CAT 2005, right? Now friends, let's see this problem. Consider the triangle ABC shown in the following figure, where BC is equal to 12 cm, DB 9, CD 6, and angle BCD is equal to angle BAC. BCD is equal to angle BAC. That means this angle and this angle is same. Now we have to find out the ratio of the perimeter of triangle ADC to that of triangle BDC. ADC, that is the small triangle, and BDC, that is the big one, right? Now further friends, this is the case of similar triangles, right? You can see that this angle in triangle BDC, we have angle B and angle C, right? Angle B and this angle C. Suppose I name, maybe this is angle 1, right? This part. So this is angle B and this is angle C. And if we see the triangle ADC, ABC, angle B and angle A, right? Both of them are same. Getting my point? I just write it over here in triangle BDC and triangle ABC. Angle A is common between the two, right? And this angle, that is angle BAC, is equal to angle DCB, or we can say BCD. Now if two angles are same between two triangles, that means the triangles are similar. That means triangle BDC is similar to triangle ABC, right? Now if the two triangles are similar, obviously their sides will be in ratio. Now how to put their sides into ratio, just see carefully. I take triangle ABC, just write it here once again. You don't have to write it again and again. I'm just writing it for your clarity. Triangle ABC and triangle BDC. Okay, now just see carefully. See, you need to be clear how to put the sides in ratio, right? Because if you put a wrong ratio or a wrong relation of sides, then you will be getting the wrong answer, right? Now I'm comparing between triangle ABC and triangle BDC. First of all, what you have to see, this angle A, right? The side opposite to angle A in triangle ABC is BC, right? Now this triangle is equal to this triangle. Now in triangle BCD, the side opposite to this angle is BD, right? So this way you have to put. Then in triangle ABC, side opposite to angle B is AC. I am putting the sides of triangle ABC on the numerator, in the numerator, and this angle side opposite to angle B in triangle BDC is DC, right? Now this is BC, this is AC, then this is the third side, AB by BD, DC, BD, DC and BC. Right? Now here what we have done, we have compared the sides, right, of both the triangles which are similar. Now BC is what? 12 BD is what? 9. AC is what? We don't know. DC is what? 6. AB is what? We don't know. We know the length of BD, but we don't know the length of AB. By BC is what? 12, right? Now we have this pure data. Now we can calculate the length of AC, that is 24 by 3, that's 8. So AC is 8, right? AB by 12 is 4 by 3, that means AB will be 16. Now AB is 16, BD is 9, that means AD must be 7, right? Now you have to find out the ratio of perimeter of triangle ADC to BDC. Now ADC, that is 6 plus 7 plus 8, that is 21, right? And triangle BDC, 6 plus 9, 15 plus 12, 27. So it's 7 by 9, right? I hope you are getting my point. I have proved both the triangles to be similar because two angles were same, and that is actually AA similarity, right? If two angles of both the triangles are same, then this is AA similarity, that is angle similarity. Now after proving them to be similar, I have put the sides in the ratio, that is the ratio of sides of both the triangle is same, right? After that I just put the value and find out the value of the unknown quantities. So problem is actually very simple and you don't need to go for this much paperwork, right? Finally, if you are clear, this is the final step that you have to put, right? This is the step, only this much paperwork is required. You don't have to write each and everything, right? Because two triangles are similar, that is in your mind. You don't have to write it over here. Okay, just observe it and proceed. Okay. Now this is a circle with radius 2 is placed against a right angle. Another smaller circle is also placed as shown in the figure. What is the radius of the smaller circle? This is the radius of the circle, that's 2 unit. This is also 2 unit. I assume the radius of the circle to be x, right? Now this is x, that means the length of this, I just show you over here, this is x, that means this is root 2x, right? So now this is root 2x, this is x, that is the radius of the circle, root 2x plus x, so that is this complete length from this point to this point, right? Plus this radius of the circle is equal to, now this is 2, that means this complete length should be equal to 2 root 2, isn't it? I equated both of them. This portion plus this portion plus this portion should be equal to hypotenuse of this triangle, right? So root 2x plus x, that means x root 2 plus 1 is equal to 2 root 2 minus 2. So 2 root 2 minus 1. So x must be root 2 minus 1 upon root 2 plus 1 into 2. So you can rationalize it because answer are in this format only. So that will be cancelled. 2 minus 1, 1 will be there. Root 2 minus 1, root 2 plus 1. Root 2 minus 1 whole square will be there. So that's 2 plus 1 minus 2 root 2. So that's 3 minus 2 root 2 and into 2, that is 6 minus 4 root 2. As simple as that. And this is from CAT 2003, right? So very simple question, friends. Now once again a problem from CAT 2005. 4 points A, B, C, D lie on a straight line in XY plane such that AB is equal to BC is equal to CD. And the length of AB is 1 meter. An ant at A wants to reach a sugar particle at D, but there are insect repellents kept at point B and C. The ant would not go within 1 meters of any insect repellent. The minimum distance in meters the ant must traverse to reach the sugar particle is. Now I just draw a rough sketch over here. Now we have A, B, C and D. AB is equal to BC is equal to CD, and the length of AB is given to be 1 meter. So this is 1, this is 1, and this is 1. Now the ant is starting from here, and it has to go till here, right? Now what is happening over here? It has to be away from point B and C minimum 1 meter, right? So the minimum distance that would be covered up, see, I draw a circle over here. Just wait for a moment. See, this is a circle, here the center of the circle. Now this is suppose point B, right? Now if ant travels on this line, that is on the circumference of the circle, that is of 1 meter radius, then she'll be like maintaining this distance, that is she'll be keeping itself away from this mosquito, this insect repellent, right? So it has to travel on this circumference of the circle, right? So similarly, this length is 1, so that can act, that AB can act as radius of the circle, and it can move like this up to here. After that, she cannot travel on circular path or circumference of the circle, because if she travel on the circular path, then she'll be getting closer to C point, and there also this insect repellent is there, right? So what she has to do, from B to C, she has to cover, it has to cover the straight line path, right? From B to C, it has to cover straight line path. So this is the curved path, this is a straight line path. After that, it has to reach to D. Again, she can take the curved path, right? I draw a neat diagram over here. Now this is straight line, this is a quarter of the circle, and this is also quarter of the circle. So in all, this length plus this length is half of the circumference, that is this, right? So half of the circumference, the full circumference is 2 pi r, so half of the circumference will be pi r, right? And this distance from this point to this point, from B to C the distance is 1, so from this point to this point still it will be 1. Now r will be 1 because AB is 1, that is the radius of the circle. So what we are getting, that's pi plus 1. So you just have to think logically over here. No paperwork is required at all, no detailed big calculations are involved, right? Your answer will be pi plus 1, the problem from CAT 2005. Okay. And here we just have used a very basic property of circle, that from the center of the circle, each point on the circumference is equidistant. Okay, the same property we have used over here. Now friends, here I am having a problem from CAT 2005. Consider a triangle drawn on XY plane with 3 vertices 41, 0, 0, 41, 0, 0, each vertex being represented by its XY coordinates. The number of points with integer coordinates inside the triangle, excluding all the points on the boundary, is. The problem involves the knowledge of coordinate geometry as well as basic arithmetic progression, you can say. I just draw this diagram first of all for you. Now friends, this is the situation. XY plane, this point is 0, 0, this is 41, 0, and this is 0, 41, right? Now we have to find out the points with integral coordinates, right? And the point should not lie on the boundary, right? Suppose this is O, A, B. So for that, what should be the condition? See the line AB, we can find out its equation, right? Here when x is 0, y is 41. When y is 0, x is 41. That means precisely x plus y is 41. So when x is 0, y is 41, y is 0, x is 41, right? And since we don't want the points to be on line, any of the line, that means x plus y is equal to 41. Precisely we have to see when x plus y is less than 41, right? On equal to 41, the points will be lying on the line itself, and if it is less than 41, then the points will be lying inside the triangle, right? And what is the condition? X should be greater than 0, because if x is equal to 0, the point will be on this line, right? So that means x should be greater than 0. Now similarly, y should also be greater than 0, because if y becomes 0, the point will be lying on this boundary. So now we have three conditions. X plus y is less than 41, where x and y, both of them are positive, right? Now that means I have various equation, that is x plus y is equal to, minimum it should be 2, it cannot be 1, because if x plus y is 1, that means at least one of them, one of them must be 0. So minimum x plus y is 2, then x plus y is 3, 4 till 40, right? So we have 39 equations over here to solve, but obviously we cannot solve. This is the question from CAT 2005. That means some logic must be there. Now friends, if you are able to recall the sessions of permutation combination, I have clearly discussed how to find out the positive integral solution of a given equation, right? So here I can find out the positive integral solution of this equation, and all the equations, right? And that can be generalized. I just have to find out the equation for solution for two equations, then the same we will generalize. Now x plus y is equal to, suppose here in this case the solution will be 1 only. In this case x plus y is equal to 3. How many integral solutions will be there for x plus y is equal to 3? The method I have already discussed over here, but I'll just go for a quick recap so you'll be able to recall that. A positive integral solution of x plus y is equal to 3. That means you have 3 objects, right? And 3 objects to be distributed among 2 persons, right? So 3 objects, we have 2 gaps over here. So if we choose any one of the gap, 2 distribution will be there, or 2 partition will be there. So out of 2 gaps, you need to select 1 gap, right? So that's 2C1, that is 2. Similarly, for x plus y is equal to 4, you'll be having like 4 objects, and out of 3 gaps, you need to select 1, right? So that will be out of 3 gaps, 1, 2, 3, you need to select 1, that is 3C1. So that's 3, right? So the sequence will go on. As I have told you, we can generalize that. The sequence will go on up to x plus y is equal to 40. If 40 objects are there, you will be getting 39 gaps. So out of 39, you have to select 1. So 1 plus 2 plus 3 till 39. Now this is an arithmetic progression, or we can say sum of first 39 natural numbers. So 39 into 40 by 2. So that's 780. Okay. So the problem involves the knowledge of coordinate geometry, as we have made the equation of line over here. And apart from that, if you have the basic knowledge of sum of natural numbers, that is basic knowledge of arithmetic progression, then the knowledge of permutation combination, right? So a single problem is involving 3 to 4 topics, but the problem is very simple, right? This much paperwork is also not at all required. I have done it for your convenience. I hope you are getting me, and the problem is from CAT 2005. I repeat, a very simple problem, should not take more than like a minute to solve. Once again, the problem from CAT 2005. PQSR are points on circumference of a circle of radius r such that PQR is an equilateral triangle and PS is the diameter of the circle. What is the perimeter of quadrilateral PQSR? First of all, I just draw a rough diagram. Now friends, once again I am having a problem from CAT 2006. Here, the length, breadth and height of a room are in the ratio. If the breadth and height are halved while the length is doubled, then the total area of the 4 walls of the room will be. The area of the 4 walls is 2HL plus P, that we know, right? Now, length, breadth, height 3, 2, 1, we consider them 30, 20 and 10. Right? So initial area will be 2 times, that is 20 into L plus B, that is 50, right? So that's 1000, right? Now what is happening? Breadth and height are halved while length is doubled. So height is 10. So now 2H will be 10 L plus B, L will be 60 and B will be 10, right? So it's 60 plus 10, 70. So that's 700, right? Now we are asked about the percentage increase or decrease from 1000 to 700. That means from 100 to 70. That means 30% decrease, right? Problem from CAT 2006. Okay. Now, once again, the problem is from CAT 2006. An equilateral triangle BPC is drawn inside the square ABCD. What is the value of angle APD in degrees? Right? I just draw this square, this A, B, C, D, and this BPC, that is an equilateral triangle, right? Now this angle must be 60, this must be 60, this must be 60, right? And this must be 30. And we have to find out this angle. Suppose it is X. Now this length is equal to this length, right? Because the triangle is equilateral, that means these two lengths are equal. And this length is of square. So this length is equal to this length, that means this length will be equal to this length, right? The same thing will be over here also. So this angle is 30 degrees. So this angle will be 75. This angle will be 75. Similarly, this angle will be 75, right? So 75 plus 75, 150. 150 plus 60 is 210. That means this must be 150. Getting my point? The center angle must be 360 degree. It is 150. 150 plus 60, 210. 360 minus 210 is 150 degree. That means this angle must be 150 degree. A very simple concept, friends. Okay? From CAT 2006. This problem is also from CAT 2006. A semicircle is drawn with AB as diameter. From C, a point on AB, a line perpendicular to AB is drawn, meeting the circumference of the semicircle at T. Given AC is equal to 2 and CD is equal to 6, we have to find out the area of the semicircle. So precisely, first of all, we have to find out the radius. Right? I just draw a rough diagram. Here, this is A, B, this is C, this is D. Now this is radius, that is R. This is center. OA is also radius, so, and AC is 2. That means this value will be R minus 2 and this length is 6. Now simply you just have to apply Pythagoras theorem. R square is equal to 36 plus R minus 2 whole square, that is R square minus 4R plus 4. Right? So 4R is equal to 40, that means R is equal to 10. Area of semicircle is pi r square by 2, that is 100 pi by 2, that's 50 pi, right? As simple as that. And the problem is from CAT 2006, right? So very simple logic is used over here, no complications. Now we have this problem. A circle cuts a square at 8 distinct points such that each side of the square contains a chord of circle equal to the length of radius of the circle. Find the ratio of area of circle to that of square. I assume the radius to be 10. That means area of circle will be pi r square, that is 100 pi. Right? Now I have to find out the area of the square. Now this is this length is equal to 10 because that is the radius of the circle and it is already given. Now if we drop a perpendicular from the center of the circle to this chord, that will bisect this chord, right? So that's length, this is 5 and this is 10. So we can calculate this length. This length is 10 and this length is 5. So we can calculate this length. So that will be like 100 minus 5, that is root 75, right? So double of this will be 2 root 75. Right? So that will be actually side of the square, right? So area of the square will be 4 into 75. So that's pi by 3, right? A very simple questions, friend. I hope you are clear. Now let's try this problem. In the figure given below, angle BAC is equal to DBC. DBC. AC is to BC AC is to BC is 3 is to 2, right? If the area of triangle ABD is 20 centimeter, ABD is 20 centimeter square, what is the area of triangle BDC? Now friends, we have these two triangles, triangle ABC, just write it over here, and triangle BDC, or we can say BCD. Now we can see that angle DB, this angle is equal to this angle, right? I suppose, okay, this angle is equal to this angle, and this angle is common between these two triangles, that is triangle ABC and DBC. That means these two triangles are similar to each other, right? Triangle ABC is similar to triangle BCD. Okay, now if the two triangles are similar, their sides must be in ratio. So we just put the sides in ratio. First of all, the side opposite to this angle, which is equal. So it's that BC upon opposite to this angle, it's DC is equal to, and side opposite to this will be AB. Side opposite to this in this triangle will be BD is equal to the third side ABBC, that's AC, and the third side BDDC, BDDC is, and this is BC. Okay. Now friends, we know that the area of similar triangles are in a square, like proportion to square of their respective sides, ratio of their respective sides, right? So area of triangle ABC and BCD, right? Area of triangle ABC and triangle BCD is equal to square of AC by BC, that is 9 by 4, right? Now ABC is actually ABD plus BDC, right? ABD plus BDC. Now this is cancelled. So 9 by 4 minus 1 is equal to area of ABD by area of BCD. T. So it's 9 by 4 minus 1, that is 5 by 4. Now area of ABD is given, that is 20, that means 5 is 20, that means 4 is 16. Okay. So your answer is 16. I hope you are clear. The concept of similar triangle has been used over here, and we have done so many problems based on the concept of similar triangles, right?